Hello everyone, welcome back to my channel. Today we're going to talk about two most important topics, rate limiting and Redis. These are very important topics in system design. Okay, and then we're going to actually try it out. Okay, in our Next.js application. Try to implement a simple version of it. Example. So basically, this is very important when we talk about caching, Redis and rate limiting. So what we need to understand is like caching. Okay, what problem does it solve? Every time a user requests data, your app hits the database. Database are slow, disk input outputs, network parsing. If 1,000 users request the same post list simultaneously, you're running the same expensive query 1,000 times and returning identical results. So caching says run the query once, store the result, and serve the stored copy to everyone else. That's the idea of caching. Okay, so basically whenever we fetch a data, for example, from any site here, like we go here, for example, Amazon or whatever. So yeah, you see this data here. So most likely that they're using caching. So when you refresh here, again it's appearing. You see. So this data basically is the first time it's going to the server to fetch this data from the server. The first time, only the first time. Then it's storing it in the cache. Okay, and then when we refresh again here, it's going to take it from the cache. It's not going to go to the server again. Okay, so it only does that once. That's the idea. Run the query once, store the result, serve the stored copy to everyone else. So the cache hierarchy, think of it as a layers, each faster but smaller than the ones below. Okay, so let's say, yeah, that's the idea of this. So yeah, we have L1, L2, L3 cache. This is nanoseconds, takes nanoseconds. CPU registers nanoseconds. Cache in the RAM takes microseconds. In-memory active lives here. And SSD milliseconds. And network DB unlimited, remote DB. Redis lives in the RAM. Your Postgres SQL database lives in the disk. That's why Redis response comes back in under milliseconds. Okay, while DB queries takes 10 to 100 milliseconds. Okay, that's why it's faster, because Redis is actually in the RAM. It's physical differences, not a software one. Yeah. So we have cache hit and versus cache miss. What's the difference? Cache hit is basically user requests. Okay, checks the Redis. If found, returns immediately. No DB touched. If missed, user request checks Redis, not found, then query DB. Yeah, if it's not found, query the DB. Stored in Redis, return slow path. Happens once. The goal is to maximize your hit rate, the percentage of requests served from cache, and 95% hit rate means only 1 or 2 in 20 requests touch your database. Okay, and we have time to live. Basically, cache data gets stale. Okay, like if someone updates a post, the old version sits in Redis until you deal with it. So time to live is your safety net. Like every cache entry has an expiry timer. When it expires, Redis deletes it automatically. Okay, next request takes slow path, fetches fresh data, repopulates. So basically, we will have a timer, expiry timer for how long the data will be stored in the cache. If the timer is expired, then it's going to fetch from the database. TTL too short, cache expires constantly. High DB load and pointless caching. TTL too long, user sees stale data, cache becomes a liability. Choosing TTL is a business decision. A news headline needs a short TTL minutes. User countries of birth could be cached for days. Okay, so the idea is like you shouldn't have too short time to live, because if it's too short, then there is no point, right? Every time like the timer completes, then it's going to fetch from the database, so increase the load on the DB. This is pointless. But if you put it too long, also at the same time, maybe someone will update the data, and you will still fetch. You will still let the user see the old data, stale data. Okay. So cache becomes, there's no, also this is wrong. So the best way is to choose between a good time, like not too short, not too long. Cache invalidation is the hard problem. There's a famous saying in computer science: there are only two hard problems, cache invalidation and naming things. Invalidation means actively deleting or updating cache entries. So when underlying data changes, instead of waiting for TTL to expire, so user, for example, here edits a post, okay, saves it to a database, then delete post this ABC 123 from Redis. Okay, so next request, cache miss, fetches fresh request, repopulates cache. This is hard because you must remember to invalidate everywhere data is updated. Okay, in redistribution system, multiple services might cache at the same time. Race condition, a stale read can sneak between DB writes and cache deletes. So basically, you have to make sure that you invalidate during mutation. Whenever you change the data, you should invalidate it to the cache. Like the code you shared skips invalidation entirely, relies purely on TTL simply, but means users might see slightly stale on TTL. Okay. So nasty failure. Imagine code stampede is a nasty failure mode. Imagine your cache entry for popular page expires. Suddenly 570 requests all get cache miss, all queried DB at the same time, all try to write to Redis at the same time. Your DB gets crushed. Okay, solution: include locks only. One request rebuilds the cache. Probabilistic early expiration. So basically, Redis is just a remote dictionary server. It uses in-memory key value stores. Think of it like a giant dictionary that lives in RAM. So basically, this is it. It stores it like this. You see the key here, post ABC123. This is the value. It stores it with the key and the value. Redis is single-threaded for command execution. So less race conditions and locking, completely predictable behavior. One at a time. So before moving on to the next topic, I think now we should actually try Redis. Okay. So I'm just going to close this one. I'm going to close this one. I'm going to type here cmd cd desktop cd clean architecture and cd my app and code this one. Let me just close all. Don't save, don't need to save right now, so just close it. Just close it. Close this one as well, close this one as well. So this app is actually running, but it doesn't have any data on the database. Let me check actually. Let me try to one second. Let me try to add something here. Tasks off. page.jsx here, storing checking the user ID here. We don't need to, or remove this one, put it. Okay, actually this is great and all, but we don't really need it. Yeah, so let me just refresh here, go to local host. Yeah, I'm just going to add new posts here. Benefits of exercise. Yeah, we just create it as it is. Let me see. Benefits. So let me create a post here. Yeah, so this is good actually. So now we can actually see the data here. Yeah, at least it's going to fetch. So we just yeah, we're just trying to see how it works. So basically right now we are fetching from a specific API here. Where is it? Using cursor pagination. So let me okay, so we have on the database, so it's good that we have some data inside the database. So what I'm going to do, I'm going to create a new API. Okay, I'm going to implement caching in it. Okay, yeah, I'm going to use Redis and implement caching in it. I'm going to use the same I'm just going to create a new API here. API, new folder for API. I'm going to call it post posts or new posts or something, and then I'm going to create here a route.ts. okay, right now we don't have anything, so I'm just going to create here. Yeah, I'm going to use the API. I'm going to create exports here, exports sync function, and it's going to be get rec. Next request, and we're going to we don't need to use next request actually, because this is a get just a get request, and we're just going to fetch a wet Prisma. I'm going to use try catch here because we have to use try catch, and let me just yeah, let me just put here the hash, try catch, and I'm going to call it errors or error, and so I'm just going to const results equals to await Prisma dot. Let's check the database actually. The database name, which is what we need, the table name, sorry, post. So I'm just going to call it from post here, and I'm going to call prisma.post.find many. Okay, just to make it simple. And yeah, then I'm just going to return next response.json. I'm just going to return the results. Yeah, so let's try to use Postman. Try to fetch from the API here, posts. I'm using post, but I think okay, it's actually new post, new here. Yeah, so basically it's working. We're getting the data, so the API is working. So now we want to implement Redis here. I'm going to do is I'm going to open Redis documentation. I'm going to go Redis here, type Redis. Note I'm using actually Upstash Redis, Upstash from Upstash here. Yeah, you can just click this one, and we have documentation here. Okay, Upstash Redis, or let's just read what they are saying here. Single platform for all your data need. It's actually very good because it gives you, it's highly available, and it has simplifies actually the process for us significantly. So we will just Upstash Redis highly available, infinity stuff. So basically first thing you need to do is like login, of course, and then create a database. Here, create a database by create database from here. Create a database from here, and yeah. So then once you create a database, mine is already created, so I'm not going to create more, but once you create here one database, and then you need to go ahead and add the region and everything. Click next, and you just use this one, connect database here, and you can choose the framework that you're using. And if you would like to use that one, also there is another way to do it. You can just select from here, like let me show you here. When you click the database, you can just connect using this one. Copy this one, just copy this one. Okay, this Upstash Redis REST URL and REST token. Once you copy it, you have to put it inside .env here, like this. Upstash Redis and Upstash token, and that's it. Actually, that's all we have to do. Okay, then in order to use Redis, we have to use something like this. We have to use something like set and get. Okay, so it shows you an example here how to use it. So let's follow their example. Okay, I'm going to go to my new post here. First, I'm going to show you exactly. Let me add here post console.log errors, and that's it. And let me just send this just to see how many. This is, it's saying 1852 ms. But it's 217 ms. So the idea is these are the, yeah. So we will compare this number with the when we use Redis. Okay, let me say I have an example here, another post here. If I do this here, this is this API I'm using Redis. Actually, you can see how the number is actually significantly changed. Let me just put it here 1 second. New post. Yeah, let's try it with our API here. So I'm just going to import Redis here from Upstash Redis, and then we are going to just check how they're doing it here. Const Redis equals to new Redis, and put it inside here, and then I'm going to put the URL, which is process.env dot yeah, I know, but we don't have to type it like that. Actually, we can just follow here. Where is the .env here? Open to the side. This one. First we'll type the URL, then the token, but we're not going to type it just like this. It has to be process dot env. 1 second. Okay, 1 second. Let me see here. Process dot env dot upstash. Just copy this one. Copy the upstash URL here. Okay, and I'm just going to put here const URL equals to this one, and I'm going to put here const token equals to this one. So I'm just going to copy this one, put it here, and then I'm going to type here the URL, comma, the token, and here we have to use process.env actually, just to access the .env here. So this is how we set it up. Now all we need to do is, once we get the result, okay, if there is a result here, if there is a results, okay, then first thing we need to do is actually store it to the Redis dot set. I'm going to call here, we can specify the key, just posts. I can just call it posts here for now, and comma, I'm going to specify here results. So okay, okay, once you fetch it, put it inside the key, and const cached equals to await post key, like, okay, and then we are supposed to check if it is yeah, we will put if it is no, first we will set it there. Okay, we will set it there. Let me check 1 second. Actually, first thing we need to check in the cache before doing anything. Before fetching from the database, we are supposed to actually check the cache. So we are supposed to do something like this: const cached, okay, equals to await Redis dot get. So it will check for posts here, and comma, it will check if cached await get posts itself, I think. Yeah, we don't need to do anything, just you can get with this one, right? If it's available in the cache, then we don't need to do anything, we just return the cache, right? Return here next response dot JSON, and we just return the cache here, cached, that's it. And but if it is not available in the cache, then we have to fetch from the database, okay? And once we get from the database the result, then we have to put it inside the cache here, okay? And then display actually yeah, put it inside the cache. Okay, and then what we need to do is actually then set it, display the results. Okay, but however, if it is so if no, then display from the database. I think this is the correct pattern. Okay, let's try it out first, and let's do one thing. Let's go ahead and check. You can see actually here from the usage or CLI, or no, not CLI, it's actually data browser, I think, or that monitor or something. Yeah, here. So actually I'm using this one, I think, e-commerce, but not, I think it's this one. Let me just try it out. Okay, let me just try this out. Okay, I'm just going to use here new post here. So it seems that it's working. You see the difference in the speed that we're getting the data, but let's see where it is here. It should show here actually, but it's not showing. Let me search for posts, because that's what we did, right? Yes. This is what, no, is this what we just fetched? Yes, I think this is the one. Let me see what happens if we fetch again. I think this is the one. So this is what we are doing basically. So actually I think it's going through the database. I just need to remove this one, delete this one for a moment, just to confirm. Okay, we are fetching from here. Now let me fetch again, just to see if it's actually going to go to the here or no. Refresh scan. See, we got it here. So it's working actually. So it's going to the Redis here. We fetch again. So it's going to the cache. Okay, so basically it's working. Working. So this is basically how we use Redis for caching. So this is the simple what we did. I just make sure that to check the Redis first. Okay, using the key posts. If already the data is inside Redis. If it is not, if it is cached already, just return the cached response. That's it, and close. But if it is not in the cache, okay, then we have to fetch from the database, right? And once we fetch from the database, we have to store it again under the same key posts, store the results using set inside the Redis. Okay, and then display what we got from the database. But basically, I think this is correct. Okay, so basically this is what caching is. Let me see. I think we can. I think we understood the idea of caching. Okay, so just like I showed you. So now I want to add timer here, just to make sure that we actually understand it. Here is cached. So this is caching. Okay, now I think we should move on to the next topic, which is rate limiting. Rate limiting and sliding window. Basically, what problem does it solve? No, but before doing that, we need to actually understand more on caching. We didn't finish this one actually. We just finished basic concepts. But we have one more topic we need to inside caching: invalidation. Manual cache invalidation. No, let me just we have invalidation here. Caching is done, so invalidation, actually validation, overall getting started. So we have already get started with this, and use cases, key store, lambda, and we have here features here. We have credentials, stash, and caching with Lateral, rate limiting, and Next.js with Redis. Yeah, basically that's what we did. Increment, counter, so db cache, validate, cache behavior, validate. Yeah, validation is actually done only when we made a change to the cache, and we can do that using, let me show you how we did it here. I did it here. Let me go to service here, how I'm doing it when I let me just type Control P, post dot service here. So here see, when I create a new post, for example, here we have to invalidate the post cache, right? We have to do that, and so to invalidate, I'm using this one. I'm importing it from invalidate cache, I think from Redis. Here we have a separate, here. So get ex string fresh get, wait, set expiry, refresh, post services, post services here, and actions. We have here revalidate path, update, delete. Post services, we have invalidate, return with cache. So basically here we're just returning the cache. 1 second, let me check mutation here, right? We are invalidating post cache here, and invalidating post cache. Okay, this is the function actually for invalidation that I'm using, and doesn't support scan, null plans. Use simple key strategy. Use upstash Redis, scan if available. This is program. Okay, so I'm just using const key to delete here, cache key, okay, posts, and I'm putting the user ID here, and I put all here, then start, then 10. Okay, public all start 10. So await Redis delete dot key dot delete. So I'm using delete actually to delete. Okay, so I am adding a specific key for each post. Okay, and then what I'm doing is I'm just using this key, I'm deleting this specific key. Okay, so basically Redis dot delete key dot to delete. So that's what I'm doing, and the request invalidation. And I have one more example here. We can see how we did it. I did it somewhere here. Redis. When I type Redis here, 1 second. Action with Redis. Let me see. Actually this one is seems a nice example to show you exactly what we did here. So I used here version based cache file invalidation. Okay, so what I did is basically I just created a function here, bump product cache version. Okay, so what I did is I use await Redis increment products version, and so to increment the product version here. Okay, so every time we make a change, we increment the, yeah, so get product cache version here we have here, and if not Redis, return 1. Await Redis.get number, okay, and product version, okay, return version. So yeah, create product. So whenever we, for example, here I created one product, what I did is I just passed it to the database, and then I pump the cache version. Okay, whenever I make any modification, I bump the cache version, and then I and then yeah, I bump the cache version, increase the cache version. One second, let me just, there is one more thing remaining that we need to cover. Okay, cache invalidation, like whenever we make any changes. So I want to show you also, before on the previous example we just we didn't use cache TTL, which is a must actually, so it will have an expiry time. TTL is just time to live, like 60 seconds, so we are telling it after 60 seconds it should be expired. Okay, and we have to use set ex instead of set. Set is okay, but for demo and explanation, but in production environment we use set ex, so to set the expiry. Okay, await Redis, set ex, cache key, TTL, and results. Okay, so yeah, so and I'm going to use a version based invalidation and key. This is how we do it in production environment. So first we will define, just like I told you, we define the URL and the token, and then we define the cache TTL, like we said, 60 seconds, right? After that it will remove it from the Redis database. If you don't mention the TTL, it's just going to store it there forever. Okay, we have to mention the TTL, and then okay, we're going to use get the current version. First step, whenever we fetch, we will get the current version, basically from get posts version here. Okay, we will create a function get post per version. This function is just going to get the post version. Okay, here this is the version, and then store it in version. Okay, if it is null, we're just going to set the version to 1. Okay, then return 1. So this first time, so return version, that's it. So let's assume it's null now, and then we're going to check version key, const cache equals to await redis.get cache key here. The cache key is here actually. This is our format that we are going to use: post public, this v, and version here. Whatever version we get from post versions, we're going to put it here. This is the key. This is going to be our key. Okay, and we're just going to check the Redis for this using this key. If it is there, we're just going to use this format: results, cached, and version. Okay, and just return this one. That's it. If it is not there, which is cache miss, then we're going to check from the database, and we're going to get it from the database, and then set it. Set ex. Remember to use set ex, set expiry. Add the key here, the cache key, add the cache TTL, and then the result. Then return the result we got from the database. So basically this is the pattern that we need to use in production environment. And what we will do in case of post or a put or whatever, we make any changes on the database, then we have to invalidate, change the version, because right now still we're going to use this first version. For example, here we will assume that we are still using on the first version here, so the user will still be receiving the old version. Okay, unless, for example, let's say now I use post here. I check the old version. Okay. First, I'm going to add data to the database, and then when I get that, then I'm going to request the version, the old version from get post version, and then I'm going to use old cache key here equals to post old version here, this pattern, and yeah, and then I'm going to post here, right? I'm going to create here. And once I create something in the database, if I add something, then it has to change, right? I'm going to use delete the old cache key. Remember, I'm going to delete the old version, the old data. Instead, I'm going to increment, which is invalidate, which is increment the post version. For example, if it is 1, it's going to be 2 now because I'm incrementing, right? And then I'm going to execute, and then const new version equals to old version plus 1, basically, and just return this one, post version, this one, status 201. So this is how it is used in production. This is best practice. We have to use this pattern for all, actually, not just this one. Okay, so let me show you in here. Right now we will assume that we have we have the we were able to fetch all this data, right, from the posts. Okay, so get is working. You see here now it's version 2. This is because I did something. It was 1, now it's 2. Okay, let me fetch again. Still it remains 2. It will remain 2 no matter how many times you fetch, because no one changed the data. But let's assume now I want to just go ahead. Okay, I will post or do something or edit on the data. Let me use post here. I'm going to manually edit here. What I'm going to do actually is remove this one, and yeah, I'm just going to remove this as well. I don't think it's required now. Remove this one and change this ID like some other number here, 5 or whatever, and title I'm going to call it go to work or something, benefits of working at Google, working at Google company. Okay, just for test purpose, let me post it. See what happened now? The version is now 3. So we incremented the version, and the old also at the same time the old data is actually gone, I think, removed. So let me show you here. Remove this one. Okay, yes, delete it, and this one here, version 3. Okay, let me change it again, change something else. Okay, see what happens. Make here any number, and I'm going to call it whatever here, make it Microsoft or whatever, or AWS. Yeah, it doesn't matter really. Next, see what's going to happen with this one. Refresh this one. 4. You see, now it's 4. 3 is removed, so no longer here. This is the 4. So this is the benefit of using version-based validation, and this pattern is very important and can be used in production environment. So I'm just going to copy this one and add here. Redis cache Next.js. No, 1 second. Not. I'm just going to use here Redis, XJS, and cache and validation and version based. So yeah, so basically this is the pattern that we need to remember. Okay, we need to practice it a few times and then we'll understand how it works. So let's go to the next